This is going to be the last episode for year 2011, and I thought we could finish by making some rhythms. So we're gonna be playing some sounds and repeating those sounds over time. We will start by playing just one sound, and then we will try to use several audio samples. So let's get started. I'm going to go here to the sketch menu and import library, and we're going to be using this minim audio library. We can see that this just adds these 4 lines, but we can actually get rid of these 3 because we are not going to be doing anything so complicated. We are not going to be using signals or analysis or effects, just the basic minim features. And like in every program, we're going to need here a setup function, a draw function, and when we create programs that use sound, we have to add this stop function, where we stop the sound engine. This is important to remember. So I'm going to start here by declaring a variable of type minim, and I could call it minim like in many examples, but I think at the beginning it may be a bit confusing to see this minim 2 times. At least it was for me. So I'm going to call this sound engine. So you can see that this is the variable name and this is the variable type. Inside the setup, I'm going to start the sound engine. So I'm going to say here sound engine is equal to new minim this. This starts the sound engine. After this line, I can start creating sounds. And I don't want to forget to stop the sound engine, so I'm gonna add it right away here to the stop function, sound engine.stop. And we have to remember also to add here at the end something like super stop. It sounds a bit funny. Very quickly, I can try to explain what is this super stop. If we don't add here a stop function, processing has already a stop function for us. But when we declare here this stop function, we are overriding the stop function that processing had prepared for us. Processing does some things in his own stop function. If we don't add this super stop, then those things that processing was thinking of doing when stopping the program will not get executed. So that's why we have to add here super stop. This means, hey processing, do the things you planned to do when I stop the program. Okay, so we have now a sound engine. We need also at least one audio sample to make some noise. So I'm gonna say here audio sample. I'm gonna call it S1. And then here, after starting the sound engine, I will say that S1 is equal to sound engine dot load sample. And I have already prepared a few samples. We can have a look at them here inside Sketch, show sketch folder. Inside the data folder, you can see that I have here 8 samples numbered from 0 to 7. I gave these samples very easy names, so they are 0.wav, 1.wav, up to 7.wav. So now here I can say load sample, and in double quotes I will start with the first one, 0.wav. Here I have to enter a number. I think 1024 may be a good number. So when this line here executes, it's loading this sound sample here into this variable, S1. Now the only thing missing is to make some noise. I have to play this sample. So I'm gonna say here, S1 trigger. I could try to run the program like this, but draw is called probably like 60 times per second. So that would mean that it's going to try play this sample 60 times per second. I think it's too much. So I'm just going to reduce the frame rate just to 3. So it will play 3 times per second. Let's see if this works. One thing I was already forgetting. I have to stop that sample here, S1 stop. Now we are ready to try it, and there you can hear this water drop, and they should be playing about 3 times per second. Okay, let's get rid of this frame rate. So now the program is again executing the draw function very fast. And we're going to be using the modulo operator, which we saw already in past episodes. We can use it to create rhythms. So instead of triggering the sample every single time the draw function is called, I'm going to check first if frame count modulo 64, for example, is equal to 0. In that case, I'm going to play this sample. What does this expression mean? Frame count is a number that always increases. It starts being 0, then 1, 2, 3, up to hundreds of thousands. if I add this modulo 64 here, this expression here would return a number that is between 0 and 63. So this also increases. It goes up from 0, 1, 2, 3, up to 63. And when it's 64, it becomes 0 again. So you can see that every 64 frames, this expression is going to be 0. That means that I will be playing this sample every 64 frames. Let's run the program and see if that's true. So now you can hear the drop falling at a much slower rate. The nice thing about this is that we can add more conditions. So I'm gonna add here another one, almost identical. If frame count modulo 64 is equal to 16, in that case, S1 trigger. So now we have two possibilities for playing this sound. What we are creating here is something like a machine or like a tape that has 64 steps. And only in 2 of those 64 steps I'm playing a sound. In the first one, and later when we reach step 16. Let's hear this. So you can hear now that there's 2 consecutive notes, which are 0 and 16, and then all the way up to 64 we have silence. So when frame count is 17, 18, 19, all the way up to 63, we don't have any notes there. Now let's add a new sample. Let's load one more audio sample here. So I'm going to create a new variable, audio sample s2, and s2 is sound engine.load sample, and this is going to be sample 1.wav, and again the same number here. So now I have declared a new variable where I can store this sample. I have loaded the sample. I have to also stop this one at the end, s2 stop. And we could, for example, replace here. We could play the first sample when it's 0, the second sample when it's 16. So this already sounds like some kind of rhythm. Let's add 2 more conditions like this. So now we have 4 cases. We can say here 0, 16, 24, and 32. And we can play S1, S2, S1, S2. So there's 2 cases where we will play the first sound, and there's 2 cases where we will play the second sound. Let's hear how this sounds. Okay, that's a different rhythm. We can also try just to change these samples here. I'm gonna use 3 and 4. Let's hear those. That sounds nice. Okay, I'm gonna add 2 more samples. Let's play 4 different sounds. So I'm gonna copy these 2. I'm gonna say here S3, S4, and I'm going to copy these 2 lines and add them here. This is S3, S4. And which sounds should we use? I'm gonna say 2, 3, 4, and 5. So we're gonna load these 4 different sounds. At the end, I have to remember to stop the sounds. S3 stop, S4 stop. And now we have to think of when should we use those sounds. So the easiest would be just to type here 1, 2, 3, 4. So then each sound will be played once. Let's hear that. Okay, there we have that kind of rhythm. Now to finish the program, let's make that these numbers here, the moment where these audio samples are played, these 0, 16, 24, and 32 can change over time. They will keep their current value for a while, but randomly, sometimes we will just change one of those moments, so one of those notes will jump to some other time in our sequence. So what I'm going to do is I'm going to store these 4 numbers in an array. Let's declare here a variable int when, and in curly braces and semicolon, I'm gonna type here some numbers. We can start with these numbers, 0, 16, 24, 32. So I can say here 0, 16, 24, 32. Now I can replace these numbers which were fixed by when. I can say here that this is gonna be when 0, So when 0 is 0. When 1 is 16. So I'm gonna use here when 1, when 2, when 3. If I play this now, it should still play the same way like before. But now the interesting part is we can change sometimes one of these values. First, let's decide here when should we change one of those values. Let's make a random condition here. If random of 100 is greater than 99. So this is going to be an event that happens very rarely. Most of the time, these random numbers between 0 and 100 are going to be below 99. But once in a while, it will happen. When it happens, we can do several things. We could come up with 4 new numbers, but in that case, the rhythm would be suddenly totally different. It will have nothing in common with the previous rhythm. But I can decide to just change one of them, not all. So let's create another random number. I'm going to call this int which is going to be a number between 0 and 4 to define which one of these 4 values we want to change. We want to change just one of them, not all. So int which is equal to int random 4. So now we have here a number that is a number between 0 and 3. We can use this number to just change the value of one of these when variables. So we can say here now when of which. This sounds a little bit funny. Remember, when is an array that has 4 values which indicate when each node plays. At the beginning, the moments they play are 0, 16, 24, and 32. But now we're going to replace one of those. And which one of those we're going to replace? Well, this variable here says which one. It's a number between 0 and 3. So now here we can come up with very different numbers. We could just say here that we're going to use a random number between 0 and 64. I'm going to make this integer. I can use here 64 because I have decided that my track or the loop has 64 nodes. So that's why I'm making up here some random number between 0 and 64. But we will see that this is not the best solution if we want to make a rhythm. But let's hear how it sounds. So you can hear that for now the rhythm has not changed. And now you can hear that some notes are starting to jump around. But the problem is that if the notes are in totally random positions, then it sounds a bit like the drummer is a bit drunk. He's not very precise. Not every single position in our 64 note track is ideal for making rhythms. There are some moments which are better to hit the drum than in other moments. So instead of allowing the program to create a random position, any random position between 0 and 64 or between 0 and 63, I'm gonna say that it has only 8 options. So now it's creating a number between 0 and 7. But we have a slight problem here. We know that our track length here is 64. We have 64 possible moments in time. And here we're just getting 8. So what can we do? I can multiply this by 8. If I multiply 8 by a random number between 0 and 7, then I will get a random number that is between 0 and 63. But there are only 8 possible values it can have. You will have to think a little bit about this expression here. There's no time in this episode to explain it, but let's enjoy the sound now. I hope you have learned something interesting and you had some fun programming during these episodes. I will be happy to read your comments below each video in funprogramming.org. So I wish you a happy end of 2011.